Now, the homework was quite convoluted, so we're just going to do a short bit on the notes today on the nature of quadratic roots. And this is on page 31 of your notes booklet. So page 31, and we're looking at the nature of quadratic roots. So remember, when you solve a quadratic equation, for example, if you're solving, let me move this on some paper. If I'm solving the equation x squared minus 5x plus 6 equal to 0, I get x minus 2, x minus 3 equal to 0, and x is equal to 2, or x is equal to 3. What that means is that when I draw the graph of this function, 1, 2, 3, 4, the graph of the quadratic, which is either U-shaped or N-shaped, is going to cross the x-axis at those 2 points, when x is equal to 2 and when x is equal to 3. And think about what it means. I'm saying that when x is equal to 2, my function is equal to 0. Y is equal to 0. So when x is equal to 2, y is equal to 0, which gives me, of course, the point 2, 0. And when x is equal to 3, y is also equal to 0. So I have the point 3, 0. That's what it's talking about. Well, when x is equal to 0, y will be equal to 6, just as a note there on this one. When x is equal to 0, if I subbed in x equal to 0 here, I'd get y equal to 6. So the point 0, 6 is also on my graph. I have 6 up there. So if I want to draw a sketch of this graph, I know that it's U-shaped because it's x squared. So x squared means I have a U shape. If I have a minus in front of my x squared, that means I have an N shape for a quadratic graph. So the sketch of this graph is going to look like a U-shaped graph that cuts the x-axis at those 2 points. Okay, it's not the neatest graph, but that's the idea. That's the idea of what's happening. So in general, the roots of a quadratic equation are the points where the graph of it same quadratic function crosses the x-axis. That's really important. So roots and x-axis points. That's what we're talking about. Now, there are 3 possible situations with roots of quadratics. And let's look back on our page 131. I'll come back to what's written up here in a second. But first of all, either it crosses it at 2 different points. So if the graph of my quadratic crosses at 2 different points, then we say that the graph has 2 distinct means different, real roots. If the graph touches the x-axis at one point, like that, it doesn't ever actually cross it as such, it's just sitting on it at one point, we actually only get one value. So an example of this would be if I tried to solve this kind of quadratic. If I was solving x squared minus 4x plus 4 equal to 0, and what I get is x minus 2, x minus 2. I just get one value like that. So I only have one point where my graph will cut the x-axis. And what that looks like when we actually draw the graph is that it's touching the x-axis at this. So if my graph touches the x-axis, Well, we don't actually say that there's one value. We say that there's still two values, but that they're equal to each other. And if we look at the solution back here again, I did get two factors. It's just that they had the same value. So that's what happens when it touches the x-axis. And there's the final case where it floats above the x-axis. It never intersects at all. It never cuts the x-axis. And we say that these roots are complex or imaginary. And what does that look like? Well, if I try to solve something like this, I try to solve x squared plus 4x minus 4 equal to 0. Okay, there are no two numbers that will add to give me a plus 4 and multiply to give me a minus 4. So we might try our minus b formula, minus 4 plus or minus the square root of b squared minus 4a. I apologize, I should have kept that a plus 4 as well. 4ac like that, all over 2a. And what happens is, when I put that into my calculator, I get an error. Because what I get is, oh, that's actually equal. I chose a bad example, I apologize. I'm just going to do it again. Solve x squared plus 2x plus 4 equal to 0. So now, when I try and do this one with the minus b formula, I've got minus b plus or minus the square root of b squared minus 4ac all over 2a. So when I put this into my calculator, I end up with an error, because what I get underneath here is 4 minus 16. I get a minus underneath the square root sign. Okay, I get a minus underneath here. A minus number under the square root sign. Now, sometimes that's happened to us when we've mistyped and you've entered something into the calculator wrong, but you can't have the square root of a negative number. If you try and do it, if you try and put it into your calculator, I'll leave it to you guys to think about why you can't have the square root of a negative number. If I try to get the square root of minus 12, my calculator just says I have an error. You might go, okay, well then maybe it's just the square root of 12, but it's not. They're not the same thing. 12 and minus 12 aren't the same number. So we do deal with square roots of minus numbers in maths, and we say that this is an imaginary number. Okay, so if we have a square root of a negative number, we call it an imaginary number. Right, so those are the three types of roots that we can have. Let me just take a look at them here. And I'm not actually going to give you homework on this tonight, because I'd like to do a few more examples, and you had enough to do with correcting your homework from yesterday. So if you're happy enough with the homework from yesterday, you feel you understand it, you've taken these important notes here. If you want to take down these notes and put an extra sheet into your notes booklet right next to this, you can. But this was really just revision of what we've done in third year. So you don't have to take these down, but it might be useful to you to look at these examples if you want to, next to the different types of roots that we have. So these were the first type, two distinct roots. These were the second type, one root, or two different roots, but they have an equal value. And this was the third type, imaginary roots, or sometimes called complex roots. So A, B, and C here. A, B, and C. Okay, thank you very much.